Okay, welcome to ISE 741 class, 3D printing class. And so basically, this is the second time I give this class. I think first of all, I would like to give you a little intro about myself and this class as well. Let's start. So I was informed there will be the captionist available for this class. Are there the captionist here? So I didn't see them. But anyway, I will try my best to caption if they are not able to join for today's class. I will caption this video myself and post it on the YouTube channel. And also for the next classes, I will be sure they will join us and provide the service. All right. Okay. So let me share my presentation slides. Can you see my screen? Is it the presentation screen?
Yep.
Okay, good. So let me skip to the presentation mode. So a little bit introduction of myself. So I'm an assistant professor of industrial and system engineering, and I joined IIT in January 2019, roughly 2 years ago. All right, and I got my PhD from the Chinese University of Hong Kong, and I spent a few years as a postdoc associate at Purdue University. So before I joined RIT, I was an assistant professor at Tennessee Tech University. Also, you could see some nice pictures of those campuses I've been there. So a little bit about my research. A big chunk of my research is the design and computational methods for additive manufacturing. As you can see here, one aspect is the customized design for additive. So basically, the focus will be how could we design complex shapes printed using additive manufacturing, as well as the capability that an ordinary people could utilize additive manufacturing, right? So how could those normal people design and customize their own products and print it using 3D printing? So that's the focus. Another aspect is the so-called generative modeling. So if you ever used the Autodesk Fusion 360, there's a module which is the generative modeling module. And for the generative modeling, so the idea is you could save a lot of material. So basically, you are not just having a solid shape. Instead, you will have material removed on the product. Only the critical regions there will be material. So you will have a really good weight reduction. That is critical for many applications like the one shown here. Basically, you want to protect yourself using wearing those casts or braces, but you want to have a lightweight wearing protection instead of a whole solid cover, right? So it will bring more ventilation there, as well as a reduced the weight. Another application for the generative modeling will be the engineering applications, specifically for the aerospace and airplane parts, right? In those parts, a critical requirement would be how to reduce the weight. So the weight is so critical. It will save it will save the amount of fuel used, and also essentially the cost, right? So how to optimize the performance versus the weight, that is very critical. And the generative modeling, again, can help for such kind of applications. And my job is to provide a tool with the generative modeling capability for the designer to design their products. So on the bottom, there are two directions. One is the so-called 4D printing. So basically in 4D printing, the product is originally printed in 2D shape. And after applying some activation force, for example, if you apply the heat to the 2D pieces, or sometimes people use the magnetic field. And with these driven force, the 2D pattern will fold it, will self-fold it or self-assembled to a 3D shape. That's the idea of 4D. So why it's 4D? That is 3D, 3 dimensions. The length, width, and height plus a time, because you need time to apply those activations. So that is why people name it 4D printing, right? That's the idea of 4D printing. But how we could find out the 2D patterns such that the final 3D folded shape are the one you are desiring. So that's the research question, right? Another piece of work is the multi-axis additive manufacturing. So instead of just having the X, Y motion and Z motion of the additive manufacturing, how about we introduce more degree freedoms? We make the platform rotate, we make the printing head tilt it and rotate. And by introducing such a multi-axis, we could have a better tool path planning, we could have a better shape and functionalities, so on and so forth. But how to plan such kind of motion to achieve the printing, that will be the critical question need to be answered. So that's the multi-axis additive manufacturing. So basically it tells, I mean, this slide tells why I'm teaching this course, because basically my research work is closely related to additive. But another, if take a look at of my research in a broader, I would say, perspective, basically I'm looking at the relationship between the machine and human. So I'm basically, what I'm trying to do is to establish the computational method or interface between human and machines, or the computational method. And as you can see here, these four pieces of work are all centered by human. So basically, how could ordinary people, how could everybody to express their creativity by designing and fabricating some customized products? That's the centric question I'm trying to answer. So for example, the augmented reality or virtual reality could be utilized to to connect human with the machine. And how could we embed the requirement of manufacturability or fabricability during the design stage? So if you are a designer, you will face some awkward situation. That is, well, what you designed cannot be actually manufactured. Basically, you are just basically what if you just look at the appearance or the shape of the design and ignoring the fabricability or manufacturability turns out what you designed can hardly be manufactured. So if there's some tool help us to embed the requirement of fabricability or manufacturability at the design stage, that will be the best case scenario, right? So that's another piece of work. Then the other social science need to be considered in the development of the tools for design and manufacturing as well. For example, how to lower the cognitive load for the user to use the tool, right? People usually, I mean, for our engineer students, basically we just automatically adapt ourselves to the tool. But for a broader user base, meaning everybody or ordinary people, they will feel really difficult when they use some of the tool, and it turns out they give up. But that's not the case for us. For the tool developers or computational, geomists. So we need to figure out a way that that is when we develop the tool for the users, we should consider about their effort or difficulty at the very beginning, right? And try to lower such requirement for the cognitive load. So that's the idea. That is, how could we develop tools, engineering tools for the novice or ordinary people, right? So the last aspect is some of the functions embedding during the design and the manufacturing. So using 3D printing, you can create really complex geometry, but that's it, right? You only have the geometry. Sometimes only the geometry will lead a better performance, a good functionality. But sometimes it's not just enough, right? We need to embed the functional parts, components into the additive manufactured appearance. But doing that is not that easy. Also, it could bring some defect for the structurality and the bearing of load. So how could we embed the functional parts or components to the additive manufactured parts automatically? That's a very interesting question as well. So I'm also looking at that aspect for my research. But overall, you can see I value the relationship between human user and the machine a lot, right? And basically what I'm trying to do is to lower the barrier for the user and make the user and make the human user and the machine closer, right? That's the little intro of myself. And now that's your turn. So I would like you talk about your background and your thoughts on this class, including what's your expectation for this class and what's your interest? Because you are, I don't know, but I assume most of you are graduate students. Probably you will have some research interest. So talk about that a little bit. And also, if you want to share with others about yourself, feel free to share. All right. I think that's, let me stop the sharing. I want to see, if possible, I want to see your face. If you want to turn on the your camera. So who wants to go first? Maybe let me try to start this myself. Oh, I see Jake is here. So, I forgot to introduce two TAs of this class, and I saw Jake is here already. So Jake, can you give us a little intro to start up this session? Oh, okay. Okay. So Jake has no camera. So okay, let me start this. So on my left-hand side, there's a one student, Louis Widom. So can you, yeah, you want to talk about?
Sure. Hi, everyone. I'm Louis. I'm a second-year PhD student in Dr. Gaborski's lab in biomedical engineering. And I'm currently working on modeling something called the blood-brain barrier, which is the interface between blood vessels and your brain. And it's really important for a couple of reasons. Mainly because when that barrier breaks down, chemicals and different cell types can infiltrate your brain and cause a lot of different neurological diseases. So people study it for that reason, and it's also interesting to study for drug treatment because if you want to treat something in the brain, it's really hard to get drugs through that barrier.
Right.
So that's what I'm currently working on is making a in vitro model with cells on a chip that we can then study under a microscope. So I'm also, because of that, I'm also working a lot with high quality imaging techniques. As far as 3D printing goes, Dr. Gaborski's lab actually just got a new 3D printer last semester. We're all really excited to start using it.
Good.
And
What kind of printer it is?
it's a Formlabs 3.
Formlab. Okay,
Yeah.
good.
Yeah.
So have you used that before?
I haven't used it yet. I'm looking forward to it.
Nice.
And part of my interest right now, at least for this this blood-brain barrier project. So like I said, we're growing cells on these really small chips, and I want to do a study where I keep the cells alive for like a long time, and sort of track them, basically doing live time-lapse imaging of the cells.
All right.
We don't have a platform that's compatible with our microscope to keep these cells under what we call a stage top incubator. So it's an incubator that keeps the cells at the right temperature and keeps the CO2 concentration at the correct level. But we basically I'm planning on 3D printing a platform that will be compatible with these chips and compatible with our incubator.
I see.
So that's just one idea, and I'm sure I'm going to come up with other ideas for the printer as the semester goes on.
Yeah, that's interesting. Actually, what you mentioned, the Formlab machine, basically that's one of the stereolithography based printer. I know some of the research. They actually utilize also the stereolithography, but not the ultraviolet, which Formlab's using. They use the natural light, such that they won't kill the cells. So they are building the tissues or scaffold using natural light and those light-sensitive material to build the organ or tissue, and at the same time keep the cell alive. I think that's an interesting direction to think of. But yeah, welcome to join the class, and hopefully you can have some fun here, right?
I'm sure I will. Thank you.
All right. So on my right-hand side, there's a student. I don't know whether my pronunciation of your name is right or not. Correct me, okay? I think, I guess, Ximena?
Samina, yeah, you're right.
Okay, thank you.
So my name is Samina, and I am currently a fifth year student at RIT. This is my last semester here. And so I'm basically have dabbled a little bit of experience in 3D printing, where back in my first co-op, I was at a medical manufacturing company.
Mhm.
And what they did is that for the industrial engineering part for that, they were able to utilize the 3D printing. It was more of a sand material. I can't remember what the material was
Uh-huh.
called, but it was a
Okay.
polymer type of.
Polymer. Okay. Hmm.
Yeah, and what they did is that they used that for like holding up the certain work instructions up, and so that way it's easier for the operators to be able to see up above, so that way they're not on the table, so that way they're looking down for it. It's for ergonomic reasons. And then for my second co-op, I remember they used it was more of a plastic
Hmm.
um, kind of a 3D printer, and this one was during um, during COVID that happened, so they were able to utilize that for to print out the mask extenders, so that
Hmm.
way they can distribute that for everybody who was working
Yeah.
on the plant. So that was pretty much my experience with the 3D printing class. And so basically my expectations for this class is that I want to be able to understand how to use the 3D printer on my own, so that way that I know how to use the basic programs and be able to
Hmm.
use the files and print out my own stuff. So
Nice. I mean, I, so I'm pretty sure you will get to know how to use the 3D printer. And also, right now, some consumer level 3D printers are really cheap. Some of the machine in our used in our lab only cost hundreds of dollars. I mean, that's,
okay.
I mean, compared to some, I mean, it's not that cheap, but still, just imagine it's just same price as a cell phone, right? Something like that. So and plus you could build, I mean, no limits, right? All different kind of shapes, and they're quite reliable as well. So I'm pretty sure you will have fun there with our machines and the lab sessions. Also, the bio, I would say, but the bio applications are I would say, quite convincing application area for 3D printing, because that requires first the complex geometry, and second, many times, the customized shape, especially due to this COVID. And there are many cases, if you use those the universal device, it just does not work. Uh, Instead, you need to customize your device to better fit the requirement in the application. So definitely that will be introduced in the later lectures as well. Okay, welcome.
Good. Thank you.
Yep. All right, I see Aubrey Holland.
Hi, everyone. I'm Aubrey. I am currently a fourth year. I am in the chemistry material science BSMS program. My research directly pertains to 3D printing. I work with Dr. Lewis, and we're working on developing 3D printable self-healing polymers. So I'm really hoping to, kind of like Ziamana, just kind of learn how to use a 3D printer and feel comfortable using it myself and everything, because my ultimate goal would definitely be to start working for a 3D printing company. Like, I actually really like Formlabs and everything. I've been to a couple events there and everything.
Nice.
So yeah, I'm really hoping this can just like solidify where I want to go after I graduate.
Yeah, that's really nice. And basically, you will be learning the basics of 3D printing, as well as some of the pro and cons. That will definitely, hopefully, help you to solidify your thoughts on the 3D printing. And also, because we have several several researchers working in this towards this direction, and you will know some cutting edge research, what is going on right now, right? And that will hopefully help you as well.
Awesome.
Okay, thank you. Thank you,
Thank you.
Aubrey. Welcome. All right, let's look at the second row on my screen. I have Dennis Grimon.
Hi, I'm Denise.
Oh, Denise, okay.
Yeah. Similar to Aubrey, I'm also in the chemistry material science BSMS route. And I am currently working with Dr. Taboda Serrano, and we're going to be looking at how the structure of a titanium dioxide catalyst, like how the structure affects its hydrogen evolution activity that it has. I've actually don't have any experience with 3D printing, so I'm actually just kind of excited to learn more about it. I think it's a really interesting field and just topic, and like Aubrey said, there are like jobs out there pertaining to it, so I just think it'd be really interesting to just, you know, dip my toe into
Yep.
3D printing.
Exactly. I mean, no, I would say the. I mean, to be honest, I would say a few years ago, 3D printing is on fire. I would say it's on the peak of the popularity. I mean, everybody is talking about. Now it's kind of in terms of the people. I mean, it's a little off of the spot, but still quite popular at this moment. And people are actually becomes more critical. On the other hand, they realize the necessity of 3D printing and realize what is the pro and the cons. So they utilize 3D printing and look at the 3D printing overall more rationale and with more rationale. And that's really nice, I would say, to me as a researcher in this domain. That is really nice situation. But on the other hand, it becomes a normal manufacturing process for us in daily life. So that is very, I mean, I can see the necessity for everybody in the engineering associated or biomedical associated area to at least take a look at it and get to know what it is, know the foundations, and such that will benefit your future work or study. So I'm glad you decided to join this class, and welcome, Denise.
Thank you.
All right, I have Q Hernandez.
Hello, everybody. My name is Quentin, but I go by Q. I am a fourth year in the Chemical Engineering and Material Science BSMS program. I don't have any research experience up to this point, except for my freshman year. It was involving basically surface adhesion peptides on like a medical device that allows, at the time, I didn't really know what I was getting into. And it was just like a freshman project, so it wasn't anything like too interesting. So that's all the research experience I have. This semester, I'm looking to work with one of the professors in the chemical engineering department. And so I'm still working on that. In terms of 3D printing, I have experience in high school just going through a couple of design courses.
Mm-hmm.
We used Ultimaker 2s.
Yep.
And so that's kind of when I like really got interested in 3D printing. I used Autodesk Inventor.
Yep.
I don't know what RIT uses, but it's probably not that.
It's a Fusion 360.
Okay. So
yeah.
I'll have to get into that. And then I just recently, over this winter break, got a 3D printer. Have been using that a lot, but a lot of it has been using like Thingiverse or other websites to download stuff. So I want to learn how to like optimize, the whole process of I see a problem and I want to make it myself without having to rely on some other people's designs. All
right. Sounds good. I mean, you mentioned a very important points for the additive, that is design. And because it's, I mean, although you need to tweak some of the parameters and setups of the hardware, but you will see it heavily rely on what you designed and how you design it. And hopefully you could have a little practice on design yourself in through the project session. We have a project, and I will talk about that in more details later in our class. But in short answer, that in short words, basically we will have little topics. You want to design some of the, it could be a toy. Last time I asked students to design a speeding car. And they will prototype using the 3D printer, all different types of 3D printer, and assemble them together with the electric motors and also the remote control system as well. And turns out the ultimate goal will be, okay, you could let the car run and they will have a competition. But due to the COVID, they have, I mean, at that time it's really serious. I mean, the situation is really serious. So they were not able to prototype it. But this time, because we have the in-person lab, so hopefully we could have the chance to actually design and prototype and test. But I'm still thinking about what will be the topics. Last spring we have the car, right? And the semester before last spring, they prototype a Nerf gun. So I'm still thinking what kind of products or toy you want to design and fabricate. Also because of the because we have more lab sessions, we have to make the less people staying in the same lab at the same time. So probably I will lower the difficulty of the project because it may require longer time, and that could cause trouble when everybody is trying to use the lab. So I will probably make adjustment and lower the difficulty, but still good enough for you to explore what you learned in the lab. All right. All right, thank you and welcome, Q. So next I have Tori Adler. Just correct me.
No, that's it. It's Adler.
Adler, okay.
So my name's Tori. I'm a 5th year mechanical engineering student this year in the dual degree program for BS in mechanical and then a master's in manufacturing. My experience with 3D printing is fairly limited to like personal use. So I have my own 3D printer and I use it similar. Someone said before they download from Thingiverse and print from there. So that's similar to what I do. Sometimes I use it to print minis for D&D, but other than that, not much. So what I'm looking to get out of this class is to learn how to design for actual like industrial use and to get a more broad understanding of 3D printing in like a manufacturing or like a workplace setting.
Okay, sounds good. Yeah, I think many of you, I mean, Tori, you have experience with a 3D printer, but sometimes you want to dig more about the some of the concept and why they make the 3D printer like this, right? Sometimes you will have the question like this, and hopefully this class will give you some of the idea about it, because we will really dig into the details about some calculations and also the component level of the 3D printer, and turns out I think after this class you could know better about your own 3D printer as well. All right.
Great.
Thank you. Mm-hmm. Okay, next, Michael Duncan. Yeah.
Hello, I'm Michael Duncan. I'm a 5th-year industrial engineering student. The main reason I wanted to take this class is because I've got some experience I've done a lot of CAD modeling, but mainly in reductive methods like CNC. So I kind of want to get a little more experience in the additive, more of the focus on the 3D printing. I've done a little bit in high school, but that was just like, I don't even remember the program it was because it was so long ago. So it'd be nice to try and get some more experience and learn how to do. And plus 3D printing just seems a lot more fun.
Yeah, sounds good. Yeah, I mean, you will find the difference between the subtractive based what you talk about the CNC and the additive. So it's kind of the opposite way of the subtractive processes, and but still it has pros and cons, and you want to learn it in a I would say a comprehensive way, and hopefully you could have some ideas when you choose subtractive and when you choose the additive. And that's one of the goal I would like to achieve after teaching you all the informations I prepared. All right, thank you. So we have Eric. Yeah, I'm not sure how to say your last name.
It's LaRue.
LaRue, okay.
So I'm Eric. I'm a 5th-year mechanical engineering student in the BSME program. I was originally thinking about going into the new product development concentration, but I'm actually going into a different concentration now, but I still wanted to take this class just because it kind of interests me and I don't really have much experience in 3D printing. So I just thought it'd be a good tool to learn.
Yep. Yeah, I think to get to know the capability and the limitations, that's essential for you. I mean, for everybody of you, and to when you make a decision to fabricate something or design something, you will take consideration of these, right? So that's a good point. Thank you. The next, Jillian, Copat. Just correct me if I'm wrong.
Oh, you got it. I'm Jillian. I'm also a 5th-year mechanical engineering student in the BSME program. I don't really have like a cool project or other reason to take this class other than I think 3D printing is pretty neat, and I would love to learn more about the different methods and different materials and just have like a more detailed understanding of it.
Yep. Nice. Yeah, there are different materials there in the 3D printing facilities we have at RIT, and probably we will explore, I mean, mainly the polymer and plastic based, but we do have the metal printers, and I'm trying to arrange some of the demonstration sessions for you to look at how those metal machines work. But still, it rely on the schedule and also the availability. But I will keep you guys updated. All right.
Perfect.
Okay.
Thanks.
Thank you, Jillian. So the next, Jessica Block.
Hi, I'm Jess. This is my first year at RIT. I am a mechanical engineering master's student. I don't have a large amount of experience with 3D printing. I did in my undergrad print sensor mounts for my research group. But other than that, I'm just really interested in kind of how 3D printing works in general, as well as being able to 3D print. So
Nice. Yep. So in this class, we have both the intro part as well as some in-depth content about 3D printer, about different 3D printing process. And I think that it follows basically it follows the sequence from starting from the polymer based to metal and powder based. I mean, as I mentioned, the most common ones are the polymer or plastic ones. So you will be familiar with these first, and then go to some industrial grade printers. And hopefully you could build up a full image about 3D printing and some of the details. All right. Thank you. So the next, Hannah Hasarek.
And I am a fifth year mechanical engineering student. I'm in the BSME program, and I have zero experience with 3D printing, but I always thought it was interesting.
Yeah.
And especially it's in a lot of industries now, so I just want to learn more about
Right,
how to
right.
design and some of the materials and other things.
Yeah, sounds good. Sounds good. Yeah, definitely. I think so. Based on my knowledge, there are more and more company, they will value your experience with 3D printing. And basically you could put the experience taking this class in your CV or resume, and letting people know, okay, you have such an experience and what you have done in your in the project or in your study, and that helps. I mean, the goal of our department would be provide a concentration or some, I won't say a minor, but more like concentration, I would say, in our degree systems. But still, even right now, you could emphasize this. Not every university has such a facility and a capability to accommodate a 3D printing class like we have. All right. Okay, good. Thank you, Hannah. So the next, Samantha Richmond.
Yep, Samantha Reichman.
Oh, Reichman. Sorry.
Hi, I'm a first year mechanical engineering student in the master's program. I currently have no experience with 3D printing, but I do have a big interest in the design and manufacturing aspect of engineering. So I think this would be a really useful skill set to have.
Yeah. Yep. Yes, I think you are right. As I mentioned, it is the time to get all the engineering students to get to know 3D printing in some ways and somehow. And again, you could emphasize it once you complete the class and mention it in your CV and resume. And hopefully you will learn some knowledge from this class. Thank you. So let me see, almost, oh, we still have four students. I think, if I'm wrong, correct me, Mika Cedric.
Hi, I'm Micah.
Oh, Micah, okay.
Yeah, I've heard Mika before, but I'm a fourth year chemical engineering student in the material science master's program, as well as Q. I don't have any.
I don't know this man.
Come on.
Thanks, Q. I have no experience in 3D printing, although 2 summers ago, I did some research with Dr. Collison on self-healing polymers, and that got me interested in polymers, so I decided to take the 3D printing class as well.
Okay, nice. Yeah, I mean, as I mentioned, there specifically for the stereolithography and other powder-based process, they utilize the polymer material a lot. I think your experience in polymer would be useful when you get to learn those processes, and you can repurpose what you learned previously to those processes in 3D printing. Okay. Okay. Thank you, Micah. Okay, next. Carol Fries. Just
hello.
correct me.
My name's Coral Freeze.
Oh, Coral Fries. Okay.
Yes. I'm a fourth year also in the chemical engineering material science BSMS program. I do know these two, contrary to what they might say. I only have a little bit of experience with CAD programs. That's kind of the only experience I have that's 3D printing related.
Mhm.
I'm just really excited to learn more about the process and be able to use a 3D
Nice.
printer.
Nice. That's good. I mean, learning, if you know some of the principles and concepts of the process, that will make you design better. That's that in general, I would say. And also, because we will use, I mean, at RIT, we have the Autodesk Fusion 360 available. So I would like to encourage you utilize that. And if you, I will provide also the some of the learning materials, and there also support from the Autodesk to pick up the Fusion 360, and I will post it with the class going. All right. Thank you, Coral. And the next, Ariel Austin.
Hi,
Ariel.
I'm Ariel Austin. I'm a fifth year industrial engineering student. I have taken one course with Professor Will prior to now, which was like
Right.
a manufacturing class where we were exposed to, I think we used SolidWorks and like the basics of
Right.
CAD modeling. So that really interested me. I know that I want to do serial entrepreneurship, and I want to combine 3D printing with a few other things in order to benefit the Black community. That's one of
Nice.
my passions.
Yeah.
So that's why I'm here.
Oh, nice, nice. I mean, so I know you in my material processing class, and you did good. So yeah, I mean, with such a background, it's you will find some benefits because you have know the basics of the manufacturing process, especially some of the polymer based or thermoplastic based processes, and you will find there are a lot of common, I would say, common principles or features in 3D printing as well. But it has its own uniqueness as well. It has its own strengths. And that's one comment. Another thing is you talk about the entrepreneurship. And there are a lot of, when I was at Tennessee Tech University, so the students from the medical school, what they did is they came up with some business plan and idea, and they use 3D printing to prototype the products in their mind, and they testify it with the practitioners in the in the hospital, and get their feedback and make improvement. And then with the result, they are able to attend some competition, business competition, and some of them were really doing good, and they got little funding, and they started a business based on that, and then they can scale up the production and using other conventional, maybe injection molding and so on and so forth to produce their actual product. But in the very beginning, they need to figure out a way to fast prototype the product. That is 3D printing. So I can see the connection there. Okay, welcome, Ariel. Who else? Oh, I have Alex Silver.
Hi. Sorry, I don't have my webcam.
Oh,
set
that's
up.
fine.
Yeah, I'm Alex. I'm a first year master's student, but I did graduate from RIT undergrad with from mechanical engineering technology with a minor in plastics.
Nice.
I've had I guess a hobbyist's understanding of 3D printing. Actually have my own 3D printer. It's a very old Ultimaker original. So it's the wooden ones that I had to put together. Yeah, had that for a long time and have always been kind of interested in 3D printing, primarily getting to learn and try to use the other forms of 3D printing, whether it be like, as you've been saying, stereolithography,
Lithography.
some of the like laser metal
Yep.
sintering types of 3D printing have always
Yep.
interested me. Like, I don't know, I've primarily been looking at SLA 3D printers because I've been wanting to get
Yep.
into 3D printing miniatures because my Ultimaker does not have the resolution for it.
I see. Right. Good, Alex. So what you will be using during the lab session will be first the fuse deposition modeling, which is the Ultimaker's process as well. And then the stereolithography. We have the Formlabs. And second, we have the Markforged Onyx. That is, I would say, a composite embedded. I would say it's kind of a combination of fuse deposition modeling with the some carbon fiber or plastic fiber that will have a reinforcement of the shape. But we do have some powder-based polymer process, but because it's just too hazard. I don't want you guys to get risky. And we have the machine there, and we just don't use it because if you talk about powder, well, there's a health issue. So we just keep it away. But I definitely will teach you the working principles and show you videos. If you want, I can even do a demonstration, but that's optional. Another big chunk is the metal-based. We have the direct metal deposition. We have the some of the sintering machines there, and but the problem is somehow it's too expensive to let you guys, everybody use it, right? So I would rather provide a demonstration session. Basically, you guys will see how it work and have some idea about it. But again, I will introduce the working principle and some of the computational details in the lecture. But for the lab, there's only a demonstration. Hopefully that will satisfy your needs in learning about 3D printing. All right, I think we have done the intro. And again, there are two TAs. One is Jake, and I see Maria's here. Maria, if you are able to say hi to us.
Yeah. Yes. Hi, everyone. I am Maria Camila. I will be your teaching assistant with Jacob. And yeah, I will happy to work with you.
Okay. Okay, thank you, Maria. So Maria and Jake will be working with you for the lab session. And we used to have like 16 or 14 people per lab session. But for this year's situation, due to the COVID, we only have 4 people per session. So that is, we have 4 set of machine as well. That means everybody will be operate and practice on the machine by yourself, which is, I would say, a good thing compared to previous year's sessions. There are less people per session. But on the other hand, the challenge would be sometimes if you are not able to complete your lab, the following group could have trouble. So in order to avoid such cases, we will make a little adjustment on the content of the lab to make sure you will be able to complete it in 2 hours. I mean, it happened a lot last year when I taught. Basically, two hours is just not enough. So they have to wait even longer time. But in this year, it's really, the time schedule is really tight. So I would like request you to review the lecture, the lab notes first, prior to the lab. Then you will save time during the lab sessions. And second, the content for you to practice will be shortened, will be simplified, such that you could complete it in 2 hours. So that are the two changes in order to accommodate all of you during this COVID situation. And but don't worry, for this lab, for this week's lab, it's a lab tour. So the 2TA will guide you to look through the facilities at the our 3D printing lab, at the Brinkman lab, and also hopefully the mPrint Center lab. And they will give you the intros about the machines, processes, as well as some of the researches conducted at RIT right now. And from next week, you will be asked to operate our Prusa 3D printer, which is a fused deposition modeling machine. And before that, we will post the lab notes on my courses. And I mean, before the lab, you want to go through it and have some ideas. All right. So that's the arrangement for the lab. I will work with our TAs to make sure this lab will be taught smoothly, as well as you will have the same level of the teaching as previously. All right, because previously we have longer time, but this time we have the sessions is shorter, but still we want to really provide the best education to you guys. All right. I think we can have a short break, like 5 minutes. Let's go back at 11, like 15 maybe, 7 minutes. All right. Okay, see you guys in a few minutes. Okay, let's go back. So one another thing for the lab session I want to mention is basically for each of the lab, you are required to sign on a name list for that lab session. So we have the requirement for the attendance. That is because to ensure you will take the lab, because if you miss the lab, that's really a, I would say that will definitely affect you because you will be using those machines for your project. If you miss the labs, you haven't practiced to use the machine, you could have trouble when you prototype your product, I mean your design, and as well as that could cause difficulty when you understand some of the lectures. So the attendance is very important. And if you have, of course, there could be situation you cannot be there you need to let us know, me and the TA in front, in advance, and such that we will be prepared. You have something to process and cannot attend the lab. And to kind of make it up, that will be another meeting. Probably through email between me, TAs, and the students. And we don't actually have much flexibility to kind of redo the lab, but in some very particular case, we could allow the student to make up. Otherwise, we just let the student to look at the videos or some other materials we provide to get to know the content in the lab. All right. So that's the one thing about the lab. Another one is it is required to wear mask when you attend the lab session, right? Cover your face properly. That's the requirement from the university as well as from myself to kind of make sure everybody is protected. So another thing is still the safety during the lab session. And sometimes it's dangerous to touch those hot ends. Although it's not super hot, but still you don't want to get an ouch, right? As well as some of the chemistry solution, you want to touch them if you wear mask, not mask, glues. We have glues there. And you need to wear it when you touch those liquid, especially for the stereolithography. The material is in liquid form, so you want to wear glove to process them. So the one last thing is to take care of your bench, your desk, before you leave the labs, right? Because we have pretty much back-to-back lab sessions. You don't want to leave the whole mess to the next group's students. So be sure to kind of tidy it up, make it arranged and ready for use. All right. So that's the requirement for the lab sessions. Any questions so far? I talked so much. So any questions from you guys? No? Okay. All right, let's start, resume the lectures. I will give you a little intro about additives. So these logistic information you could easily find through my courses or the syllabus I uploaded. So I won't talk too much. And basically this class is a combination of lectures and labs because it really relies on the hands-on. I mean, if you just look at the slides and learn the theoretical content is not enough. You have to practice yourself, right? So that is the nature of this class, right? Also, there are some objectives. The CAD design aspects, also some of the process aspects, especially the pro and the cons for the processes, the material, part size, feature size, clearance, and so on and so forth. That will affect your design decision when you design some products and try to prototype them. All right. So if you have any question, just let me know. All right. We can stop and discuss. Don't be afraid to ask questions. All right. Another thing is the software. As I mentioned, we will use the Autodesk Fusion 360. And you should be, I mean, as a RIT student, you should have the license available. If you don't, just let me know. All right. I think the good thing for Fusion 360 is it supports the Mac operation system as well. So if I'm wrong, just correct me, because I'm using Windows and there's no problems on Windows. Also, last year, Autodesk provide some technical support as well as the free online courses for students to go through. So I will ask them for the support as well for this year's, and the detailed information I will post it once I get back from them. All right. So don't worry about picking up Fusion 360. It's pretty much same as what you've used, SolidWorks or Inventors, so on and so forth. But the only thing is be familiar with UIs and functions, and you should be able to pick it up with some support. All right. Any questions? Nope. So no textbook still. Basically, you can check my slides and the 3D printers. Pretty much we have all the materials and the supplies ready, so don't worry about that. But for some of the machines, it's really hard to accommodate because it's too costly. So maybe we just take a look at it and check videos. But for the metal, I'm trying to arrange a demonstration session again. All right. For the grading, so we will have homework quizzes, 2 exams, a midterm and a final. I mean, 2 midterms, sorry, and 1 finals. And another thing is the course project. So basically, there are some knowledges you really need to memorize and think through. That's why we have exams, also the homework quizzes. But also you have the hands-ons. So that's why we have a course project. And through the labs, you should be able to learn how you use those 3D printers, and that will benefit you when you do your course project. So you will design some objects, and of course with the mechanisms. It's not a dummy shape, but it has a functionality. And design them, fabricate them, assemble them together, and make it work properly, right? So there will be some criteria for judging the course project, and I will release that later after some further consideration, and also maybe learn from you as well, right? To listen to your idea, and we could make adjustment. But the rest, homework exams are pretty much similar to previous years. Also for the grading, if you ever take my course, the courses I teach, you will know I don't do curve. That means you get A, you get A, right? I won't do some scaling down, or no, I won't do that. So if you put your effort into the course and make sure you do your homework and all the labs properly and get to know every point of this class, you should be fine. You will get a good grade. So that is how this course work. All right. Any questions so far? Okay, good. So let's start the intro of additive. So basically, additive is right now is an official industrial standard. That means the processes of joining material to object, to make object from 3D model data. And usually it is in layer upon layer, because right now there are new processes coming out without layer on layer manner. So, but still, most of them are still in this form. And also the term additive, that is opposite to the subtractive manufacturing, right? So that's kind of a rough definition from the Wooler Association. And there are different names of additive. Now we call it additive, but in old days, people used to call it solid freeform fabrication, SFF, rapid prototyping. And another very famous name we used as well a lot, that is the 3D printing, 3DP, right? It's more like a layman name of additive. So we use 3D printing or additive the most, right? So I will let you know why the rapid prototyping or solid freeform fabrication are not popular anymore, because of the development of the processes, and also the applications of the additive manufacturing. And basically they made these two names out of date. That's why. And I will explain why. If we ever look at the development of manufacturing in industry, you will find a very interesting trend. So during the first 3 industrial revolution, we have solved one-centric problems. That is how we could produce some products faster, better, and cheaper. And turns out we come up with the automation, the assembly line, and the conveyor system, right? And it turns out we are able to produce the products in a quite affordable price. But the drawback is they are pretty much all the same. Means we are able to produce products which are identical to each other in a zillions of volumes. So definitely we won't have this, because that make these products consumer level. That's why we could afford a personal computer, a cell phone, or car. Without such kind of production rate increased dramatically, that's not possible, right? But still, we have more requirements, and that is where we are. We are kind of in the middle of the so-called 4th industrial revolution. And as a feature of this 4th industrial revolution, there are some new technologies such as cyber physical systems, industrial IoTs, high-speed network, some simulation method, and some of the VR, AR display technology, as well as the 3D printing. So in the 4th industrial revolution, the centric question is, how could we make the design and manufacturing has more automation, intelligence, and flexibility? That means we could have more customized product instead of zillions of identical products. we could have this kind of customization with more automation. I mean, right now it's possible to have customized product, but that means you need to have many actual work and actual cost. So that's not the ideal way. And it turns out the customized products are usually cannot be afforded by everybody, right? So the idea for the new industrial revolution is, could we make this manufacturing process more flexible and more automated, such that we could have customized product in a cheaper price and in a lower effort, right? Another aspect is the intelligence. I think you have heard about the artificial intelligence, machine learning, deep learning quite a lot. So with these powerful computational method, right now people are really has the opportunity to make many of these steps in the manufacturing process has more and more intelligence. So that is not possible even like 20 years ago, right? So that's why intelligence is another feature for the new industrial revolution. And so what the role additive manufacturing play in this game of the industrial revolution? Let's look at some of the benefits for the additive. Basically, it could produce complex geometry with the extra cost of molds and dies, such that it makes the customization really low cost and possible, right? As you can see here, those really complex geometry can be made without the actual cost. And sometimes it can achieve better performance, consumes less material and a lower cost. So this two shows the two customized products enabled by additive manufacturing. The left one is the teeth aligner, invisible teeth aligner, and the second one is the customized hearing aid bud. So these are the, I would say, the most successful applications for additive in terms of in the customized medical devices. Also here shows two examples in the aircraft applications. The left one is a fuel nozzle, which is 25% lighter and 5 times stronger compared to its old counterpart. And that is produced by the GE. And the right-hand side is produced by Airbus. So basically it's a nacelle bracket used in many places of the airplane as a hinge, as a part of the hinge system. So it is 30% lighter. So this kind of weight reduction and mechanical property increasing is favorable, because in the airplane or airspace area, reducing weight means a lot. That means less fuel required, less risk encountered, and turns out the cost will be reduced as well with the weight reduced. So you can see these, I would say, successful applications for additive. And another aspect is the additive turns everybody from, ordinary people from only consumer to maker. So a maker could design and fabricate their own product using additive, instead of waiting for those big companies produce the product for them. So that actually makes the manufacturing democratized. So that means a lot. Means, people who has no capital, who has no resources, could achieve their design thoughts using additive instead of waiting for help, right? So that actually essentially triggered the new production models by just having these desktop level 3D printers. So you could buy it, put it at your home, or even put it in your garage, right? And then you can design and manufacture your products. Also, there are online production shops, local production shops and online manufacturing services. So these are some examples. Basically, you just design your product, upload it to those websites, and they will manufacture it and mail it to you. So that, again, changed the way of manufacturing from a capital intensive and workforce intensive to idea intensive and I would say idea centric, creativity centric, right? If we look at a broader impact of additive manufacturing, so I always use this picture as an example. So basically, here shows a famous people, Henry Ford. He was considered as the father of assembly line. He used to talk to his consumer. You can have any color you want as long as it's black. Well, basically this quote suggests, well, you have no choice but take the black car we produce, right? Because of course, there maybe Henry Ford just didn't want to provide other, cars with other colors, but it also suggests the difficulty to customize, even just the color, right? In the way of the production, assembly line production, every step is preset and it's quite rigid. Even a small change could produce a large amount of cost, and turns out it will make the total cost of the production higher. And that's one of the reasons it's so hard to get a customized product in the way of the traditional manufacturing. But with the new additive manufacturing capability, the user could complete the design and fabricate it in one shot, right? And the designed object, the designed product could be the personalized product which satisfies your personal needs. And it could even have the functionalities. So that's the difference. And you will see why this customization becomes so easy. And I will show you some chart and figures to kind of illustrate the difference. And also, you've already seen many of the applications across every aspect of our life, right? Basically, I just list some of the applications I can find online. There are some garments, some cars, bike, even there are some applications, they print houses. Also, Adidas has a collaboration with the, what's the name? Carbon 3D. They are producing the axle of a running shoes. Basically, what you're seeing here, they are the customized lightweight axle. Also, some of the customized helmet. In the biomedical and medicine applications, you can see the printed tissues, organs, and some of the drugs. So I would say you can see additive manufacturing in almost every aspects in our life, right? So if we take a closer look of those applications, designers are able to confirm their design by building a real physical model in a minimum time using 3D printing. So as you can see here, these part are prototypes using 3D printing. So you will have the physical part in your hand and you can testify it somehow. At least you have the size, the shape, the clearance, and so on and so forth. And such that you have a more solid understanding of your design, right? That benefit a lot. It reduced the leading time to produce such prototypes using 3D printing, and you could have the improved ability to visualize those part geometry. I mean, in your imagination or just looking at the virtual part in your CAD software may not be good enough. Sometimes the part is based on some pre-existing object, but you don't know whether that will be a problem or not unless you have the physical part and fit it with the existing part, right? So that's why you want to always want to have a prototype. But using the conventional method, prototyping complex, especially complex geometry, is very difficult. But using 3D printing, it becomes much easier and much faster. Also, you could have an early detection of the design errors. For example, if some dimension or shape of the holes are not correct, you will immediately see after you have the physical part, right? And sometimes you have no idea about some of the physical properties of your part. Then with the 3D printed part, you will have the idea as well. So that's the benefit for the prototyping. And actually that's the earlier applications for additive manufacturing. And that's why people used to call it rapid prototyping, right? Because people use it for the prototyping solely. But later you will see actually it could be used for fabricate the final product, right, instead. And that's why the rapid prototyping, the name rapid prototyping is kind of abandoned by people, right? Also, another useful benefit for additive manufacture part is you could do the engineering analysis and planning. For many such kind of analysis and planning, you just need to have a physical object. For example, this kind of tunnel test, right, conducted using the 3D printed cut. Of course, it is scaled up, scaled down, but still it will give you the idea of the aerodynamics result, even using a smaller model. But the geometry is more important. So you need to prototype the part with the exact geometry, but smaller size, right? So that's how this can be used in some of the analysis. But even the shape, I mean the appearance, including shapes and the styles, means a lot for many of the production. For example, the car or some of the even cell phone, right? You want to look at the physical products with the shape and the styles to check whether it satisfies your need or not. Also, some stress analysis, you want to conduct it onto the physical models. So like the one showing here, again, it's a wind tunnel test for the air flight, right? So you want to have a physical object ready to conduct such kind of analysis. But on the other hand, you don't have to actually prototype it. You can using the conventional method, but a 3D printing can satisfy your need. Also, if you ever learn about injection molding, you will know injection molding is really good for the mass production. It's quite fast and the quality of injection molding is good, but still the cost for the mold, for the machine tools are quite are quite high. So before you decide to scale up the production, you always want to have small volumes of prototyping. And in such cases, the 3D printing or additive manufacturing is the right choice for you. Also, parts with really complex geometry like the one shown here, especially the internal geometry, that is not available for the conventional technologies, right? There's no way to produce them using the conventional manufacturing processes. The only way you could use is additive manufacturing. So if we look at this invisible teeth aligner, the customization is the essential requirement for such kind of teeth aligner. And using 3D printing will really cost less and produce faster compared to the conventional manufacturing processes. So we have talked about many of the benefits and the features of additive. If you look at this book, again, this is not required, but if you have an interest, you can take a look at this book. And in this book, the authors proposed the 10 principles for additive, and that shapes how additive becomes an additive, and it shows the benefit of the additive. And I just use these 10 principles as a guidance, as a guidelines to show you the benefits or the advantages of additive. All right, so let's look at the first one, the complexity. As you can see, these applications of additive manufacturing, which to produce these kind of high complex geometry using conventional manufacturing becomes impossible. So only additive could produce these kind of geometries. So in that sense, the complexity becomes free for additive manufacturing. And the variety is free. So as you can see, these are all different parts, but they are printed using the same machine or even same setup. I mean, same machine, same material, or even same setup. So you don't need to do the handling or do the fixturing and do the changes for which are usually need to be taken care using the conventional way. If you use conventional method, probably, for example, if you want to print this hand, it has one setup. It has one set of machine tool. Not necessary to be machine tool, but manufacturing tools. But if you switch to print this this statue, probably you will change the whole thing. And that will make this change impossible. But for additive, the only thing changed is the file. If you have the file changed, and probably you can use the same setup, same material, and that's it. So that's why the variety is free in additive. And in many cases, the assembly of the part are not necessary using 3D printing. As you can see here, this chain is printed without assembly. So this probably is printed using powder-based or using those, even using plastic-based. There's a way to avoid assembly. For example, if you use plastic-based printing, there could be some support material fill in these spaces between each of these unit. But if you use the support material, which can be which is solutable in water or other solutions, you could easily wash them away, and turns out you will have this space empty, and turns out you have the chain, the mechanism working properly. If you use powder-based, it's even simpler. So the powder will be removed easily by the blaster, right? You can blow it away easily and clean it. And it turns out this space can be kept, and you have a whole assembly ready without any actually actual assemble after the printing. Right? Also here shows some ball joints printed without assembly. But in this case, that is not the process, it is the design. If you design this properly, it is still possible to make it assembly free with a proper clearance set it up. Another idea is for the conventional parts which are made of assemblies, using 3D printing, you could merge the parts, make it a whole part. So in this field nozzle example, the original design has 20 assemblies. Now it's a whole part. So you convert a part from 20 assemblies to only one single part. That increases the difficulty of assemblies, as well as it will make the mechanical property a better way. And it could reduce the weight as well. So that's one example. Another one showing here, again, it used requires 16 parts plus glue to put them together. Now using 3D printing, there's only one part and no assembly at all. So you can see the benefit for the assembly using 3D printing. So any questions so far? Nope. Okay, let's go on. For the principle 4, 5, 6, 7, let's put them together. So basically, it talks about some of the preparation and pre-processing before the assembly. Before the manufacturing. You will have a better integrated manufacturing processes using 3D printing without those tedious and difficult preparation and post-processing. So by integrating design and manufacturing together, what you need to do is just design what you want. Of course, you want to do a little verification before you actually print it. But after you determine your design, what you need to do is just to pass the design 3D model to the 3D printer. And then the rest will be waiting for the 3D printer and get the part. So that simplifies the manufacturing process quite a lot. All right. So for the 8th principles, in general, additive, in many cases, additive will produce less waste. If we look at this extreme case, what you want to do is you want to produce a empty block. So for the subtractive manufacturing, what you start with is this large block of material, and then machining, using machining process, the cutting tool will progressively remove material, and it turns out you will have the desired geometry. At the same time, you have piles of scrapped, right? You have a lot of wasted material. These cannot be reused. Of course, you can recycle it, but you cannot directly use it for the next machining, right? But for the additive, it's the opposite way of subtractive manufacturing. So it add on material layer upon layer, and of course, there still require little machining just to remove some excess material to make it satisfy the clearance and the tolerance, but the amount of removed material is much less than using machining. So that is how we could have less waste of material and make the manufacturing more sustainable. So here you can see a comparison. If using subtractive machining to produce such kind of geometry, you have to remove such amount of material and it becomes chips. And turns out there's 20 to 1 bite to fly ratio, which is a lot of wasting, right? But using additive, you will have much less waste. So that's the waste sustainability. So the principle 9 suggests the material variations. So as you can see here, there are different colors appeared on the same products, which is difficult to achieve if you are using conventional manufacturing processes. Well, for different colors, probably it means different parts, right? For each of the parts, there's one color, and then you need to assemble them together. But using additive, you could have a single object with all different colors. And not only color, but if you look at this one, it suggests different material. You could have a soft material inside and solid material outside for the experience. If you look at this one, you can see all the different materials, colors, and structures embedded in the same printing. So it can be done in one shot. I mean, in the same printing process instead of intervention and as well as the assembly. And how you can see how gorgeous this look like, right? There's some transparency material, there's semi-transparent material, and totally solid material, and they are put together with different colors as well. And this shows another applications. So they are printing the silver ink onto the plastic material, and turns out this part will become a functional part. So you could use it as long as you take it out from the 3D printer without the actual assembly and some tedious work there. So that's the advantages in terms of the multiple material and the colors. So the 10th principle is the precise replication. So because of the additive, that could be some that could be a working pipeline that is starting from a 3D scan of physical object. And with the 3D scanned object, of course, you want to do a little repairment and clearance. But after that, the 3D file can be transferred to the 3D printer. And after printing, you have the physical object, which is a replicant of the original physical object. So actually that drives some of the business. If you look at this right-hand side figure. So basically this ballet dancer could have her own figure by conducting a 3D scanning and then 3D print the scanned 3D data. And turns out it has a scaled down statue. And some of the people, they utilize this as a business, right? And I know some of the company, they print the people's figure and sell them to those weddings. So they want to have their own figures appeared in the wedding, and they find these companies to produce for them. So that is very interesting. And also some of the applications like 3D printed food. There are pancake printed or cakes printed as well. All right. So after going through the 10 principles, there are another, I think we can stop here. It's almost 12, but there are another 2 principles as well about the complexity versus cost and unit versus cost, which are very important. Maybe we talk about it next class, and I will post this lecture notes onto my courses. You can check it in advance. All right. Any questions? No? All right.
Just one quick question.
Oh, yeah, go ahead.
Is there anything we need to bring if we have lab today?
No, the only thing is you just need to sign on the name list. That's it. Yep. Wear a mask. All right. Okay. I hope you enjoyed this class, and let's keep touch, and hopefully you will have a nice lab. Just to give me feedback if you want about the labs and lectures. Also, we have office hour on Friday. If my memory is correct, it's 1 p.m. to 2:30, right? I will be there in the meeting room, same meeting room as this one. So if you have any questions, you can just come and join. All right. If there's no other questions, okay. Let's move on. And thank you, guys. Bye, guys. Take care.
Bye-bye. Thank you.
Bye, Maria.